Hello, APPC Calculus students. In this video, I'm going to explain integration, which is antiderivative using linear partial fractions. We are going to use a non-repeating linear factors only, and we will have to review the long division as well. I do not prefer synthetic division, but if you are comfortable with that, you can use it. So let's consider this integral. So first of all, what we have learned is a u sub. So let's check if the u sub works or not. So u is equal to, let's say, x square minus 2x minus 3. I can say du is equal to 2x minus 2 dx. And you can clearly see there is x minus 1 here. So I can factor out 2. And I can, u sub works very well here. U sub works very well here. So let's rewrite the entire integral. And this is 1/2 ln x square minus 2x minus 3, and don't forget c. So this is a review of u substitution. It works very well. So let's consider another here. You cannot factor x square plus 1 and 2. So let's check if u substitute work or not. So du is equal to 2x dx. Clearly you have only x here, and I mean a 2 here, and you have an x here. So u sub does not work. U substitution does not work. So what can we do? Think about, do we have any other tool which we can use here? So clearly recall that we have an inverse trig also. And this is fits very well, inverse trig pattern, which is tangent inverse. And don't forget C. So these are the two tools we have already learned before. This is the inverse tangent, and this is a u substitute works well. Okay, so now let's consider this integral, which has the same denominator. So if I say u is equal to x square minus 2x minus 3, du is equal to 2x minus 2. And no matter what I do, this u substitute does not work at all because of this 5x minus 3, and you have x minus 1. So let's think about, can I split the factor which is 5x over x square minus 2x minus 3 and negative 3 over x square minus 2x minus 3? And clearly this one also doesn't work here. So why u sub can't work? Because integrand is a quotient rational function. None of the method works here. You can't even work further. So is there any way we can break up the denominator, which is called partial fraction decomposition? So first thing is we have to understand if we can factor or not. Okay, so let's check the method. This method is called partial fraction decomposition. Okay, so this is a review from pre-calculus. This is a review from pre-calculus, and then comes the calculus part. So let's see, can I factor this x minus 3, x plus 1? So x minus 3, x plus 1. If you recall in a pre-calculus, and this is, we cannot say this is equal to, this is my side work. So if you recall in pre-calculus, we have factored this and break it into two pieces, and as a placeholder, I can say a and b. Now our job is to find the value of a and b. So I'm going to explain one method here, how to find a and b. Left side is a 5x minus 3, right side is this is a review from pre-calculus. We have to find the value of a and b. So let's say x is equal to 3. Substitute x equal to 3. So 5 times 3, 15 minus 3 is equal to 3 plus 1, 4a plus 0. So 12 is equal to 4a, and a is equal to 3. Here I substitute x equal to negative 1. That will make this factor 0. X equal to 3 make b equal to 0. So 5 times negative 1 minus 3 is equal to, this will factor will be 0 and b is equal to, so negative 8 is equal to negative 4 and b got it 2. So now comes the calculus part. Calculus part is you rewrite this integral 3 over x minus 3 plus 2 over x plus 1 dx. Okay, so now what will be the entire derivative of this? And for this part, I told you your best friend is here. Linear factor. Anytime we have a 1 over mx plus v dx, entire derivative is ln and 1 over m ln mx plus v. What pattern fits here? U prime over u is ln u. Derivative of mx plus v is m, so we have to balance it with 1 over m. So in this case, 3 ln x minus 3, because derivative of x is a 1, so we don't have to worry about that. 2 ln x plus 1 plus c. This is the entire derivative. So PFD, this is the pre-calculus part, and the calculus part is entire derivative. Okay, so let's take a look at another example. Okay, so let's take a look at one more example here. I'm going to show that how you can factor x square plus 2x, which is factor is x and x plus 2. If we let me help you find the value of a over x and x plus 2 and b. Our job is to find the value of a and b. I'm going to show you another method here, which I call this a finger method. Finger method means if you are looking for the value of a, put your hand onto this finger, means use your hand on the x and substitute 0 here. So you will get 1 over 0 plus 2. So that makes it 1 half over x. B will be, value of b is x is equal to negative 2. So cross this out and substitute x is negative 2, which will make it negative 1 half over x plus 2. This is, we call this a finger method. If finger method is not working for you, by all means, go ahead back to the a plus b x plus 2. Other side is a 1, so a needs x plus 2, b needs x, and this side is a 1. Think about this factor will be 0 when x is 0. So substitute x equal to 0. You get 1 is equal to 2a plus 0. So that means a is a 1 half. This factor will be 0 when x equal to negative 2. So you will have 1 equal to 0 plus negative 2b, and b is negative 1 half. So that is finding the value of a and b, which is we learned in pre-calculus. Okay, so let's come back to this, and we found the value of a and b. And antiderivative of 1 over x is ln x, and antiderivative of x 1 over x plus 2 is ln x plus 2. So that's what we got here. Now, many times you have to apply the properties of log, and you can factor out 1 half, and you can say ln minus ln. So recall that ln x minus ln y you can rewrite as ln x over y. And yes, you have to know this property as well. Many times, multiple choice question, they are giving you answer like this. So this is your final answer. Okay, so let's take a look at this definite integral. This is the same as example 2. This is example 2a. So what happened? We have a lower bound 2 and upper bound of 4. So we have to come here and do partial fraction decomposition, and then you have to apply fundamental theorem of calculus, which means you have to substitute 2 and 4, which will give you let's take a look at this. ln, if you substitute 1/2, 1/4 minus ln, you are just substituting. So one more time, if you recall, f of x and a and b, you have to substitute f of b minus f of a. And you could have substitute here also, or you can substitute here. But remember, when you have a definite integral, there is no more c. So multiple choice question, all of these are valid answer. It could be this, or it could be that, or it could be this or this. Know the properties of log. This is the same example as a 2, but with the definite integral. Okay, so let's take a look at another example here where denominator has a lower degree than the numerator. So if you recall, again in pre-calculus, when you have a top heavy, we are supposed to do the division. 2x cubed minus 4x squared minus x minus 3, x squared minus 2x minus 3. So I'm teaching you one more time how to do the long division. This is x squared, this is 2x cubed, so you multiply by 2x. 2x times x squared, 2x cubed, minus 4x squared minus 6x. We always subtract. So this is gone, that's it gone. And you have numerator, the remainder is 5x minus 3. Okay, so how do we rewrite this? You have to, so you need all the factors. So this is the quotient, which I'm going to rewrite, 2x plus remainder is 5x minus 3, and you have a same quotient, x squared minus 2x minus 3 dx. One more time, top heavy, do the long division, rewrite the entire integral again. Now comes, this is a normal antiderivative of 2x is x squared. Here is the one where we have to do partial fraction decomposition. So if you recall, this is the same example as we did on the other side. That is the same example as this. So I'm going to bring back the answers from the previous example and we can look at this here. So the long division, we did the long division. Rewrite. This example is the same as the previous example. We have to do the partial fraction decomposition. Antiderivative of 3 over x minus 3 is ln 3 and 2, and this is your final answer. This is a very popular question. We have seen many times in multiple choice questions. So if you get the long division incorrect, everything will be incorrect, of course. So let's practice with one more long division. Okay, so this long division is, let me show you the work here. This is again a top heavy. So how do we rewrite this? This is very interesting question. So antiderivative is I'm rewriting 2x plus negative 2x minus 1 over x squared plus 1. Okay, so if you look at this denominator, you cannot factor. Let's see if a u sub works or not. Du is equal to 2x. Well, we have a 1 here. What to do with that? So this is, say, we are going to split this into several integrals. Negative 2x, negative 1 over x squared plus 1 dx. Okay, so some of you feel like, how can we separate this? How can we do it? Well, review the properties of fraction is if a plus b equal to c, you can say that a over c plus b over c. Nothing wrong with that. Okay, so now here we can see clearly what's happening. U sub works here because derivative of x squared is a negative 2x. Then what would you do here in this case? Then that becomes tangent inverse. So very interesting problem. Let me reveal the answer here. Okay, so let's take a look at here. U sub does not work, so we split into 2. This is u substitute works very well. Derivative of x square is a 2x. So you remember u prime over u is ln u. You must have absolute value bar anytime ln is there. And this is a tangent inverse. So that's the answer. Pretty interesting question. And yes, don't think like you are not going to see like this. This is techniques of integration. You get to learn more by different combination of the problems. Okay, so last on here is properties of log. You have to know the properties of log. Must know you cannot combine fractions, I mean combine logs if there is some coefficient here. So for example, if you have 2 ln x, you have to write it as ln x square, then only you can combine fractions. So all these three properties are being used together. Okay, so here 2x square minus 5x minus 3. Some of you don't like to factor, but yes, 2x and x. Guess and check what's all the time. Factors of 3 is 3 and 1, which will give me negative 6x and x. So these are the factors. Okay, so this is very interesting questions. So I'm going to bring the factors. Once you have this factor, so I'm going to work here, integral 2x plus 1 x minus 3, and you have to find the value of a and b. You can work on the side, and I'm going to bring that here, 1 over 7. Okay, so what will be the antiderivative of 2x plus 1? You have to factor out negative 2x, 1 over 2x plus 1. 1/7 x minus 3 dx. This piece is easy, 1 over 7 ln x minus 3. Antiderivative of this, 2x plus 2. Derivative of 2x plus 2 is a 2, which I don't have here. And this is where I was telling you that your best friend is anytime you have derivative of 1 over mx plus b, antiderivative is 1 over m ln mx plus b. So that will make it negative 2/7 1 over 2 ln 2x plus 1. So if you simplify, 2 got cancelled, and you have negative 1 over 7 ln 2x plus 1 plus 1 over 7 ln x minus 3 plus c. You will less likely see this as an answer because log minus log is combined as a single log. So let's check it out. The answer is here. You combine two logs, and log as plus log is 1/7 ln x minus 3 over 2x plus 1. The negative 1 comes in the denominator, the positive one stays on the numerator. Okay, so the last but not least here, u is cosine x. So what will be du? Negative sine of x dx. So if I simplify here, sine of x, cosine x is a u, and u minus 1, and I should have rewrite this as a negative 1 du. Okay, so let's break it apart. You can factor out negative sign, and you can say u minus 1. What will be the value of u in this case? I mean a and b. So a is when u is a 0. So if you substitute 0, you, this is cancel out. Substitute 0, 1 over negative 1 is a 1. So that means this is 1, that's a u. Substitute u equal to 1. So that's gone, u equal to 1. So this b value comes out negative 1. Again, if you are struggling on this, you can go on the side and use the value a over u, b over u minus 1 is equal to negative 1, u and u minus 1. You can find the value of a and b. Okay, so this comes negative sign outside all the way, and you have a factor. So negative ln u minus ln u minus 1 plus c. And if you combine these two together, this negative becomes positive. That will be negative, and your final answer is this. Okay, so one more time, I'm reviewing PFD. Make sure you understand the value. Make sure you know how to do the pre-calculus part. This is a review. You have to know how to find the value of a and b pre-calculus, and then the calculus comes out as a log. We have covered so many problems. Make sure you complete the homework, and these are the multiple choice questions. Practice on this. Thank you.